believe I did hit record. I do believe we're recording. I did notify everyone at the very beginning. I'm sorry if those have joined after. Please know the session is being recorded, and we're going to be utilizing this as a chance for visitors to access this content later. Thank you so much. I appreciate that. Brianna.
Yeah, no problem.
No, absolutely. And then we're going to take an overview of looking at how we might be able to engage in digital making. All right. So before we get started, though, I'm curious if someone wouldn't mind just dropping in the chat box. How many of you were familiar with the fact that we had California K-12 computer science standards? I actually somehow got out of my window. I apologize. Please go ahead and if you could respond there, I'll take a look and see if you knew that we had California K-12 computer science standards. That's awesome. That's awesome. Because one of the most exciting aspects, this is great, I'm with my peeps here. Oh, and for those of you that aren't familiar with it, you do have the opportunity to do reactions to where you'll be able to do a thumbs up. So if you look in the lower hand portion, you should see an option that says reactions where you'll be able to access that. Let me get back to my screen. I'm so sorry, guys. Let me just get back here. I got a little sidetracked, but I'm appreciative for this opportunity. Hopefully it'll come right back up. Okay, awesome. Because, you know, often when I'm engaging learners, we want to think about the idea that when folks consider things around computer science, often they'll think about the notions around coding and programming, but really it's so much more than that. So as we're thinking about ways we can look at this tool to engage students in the ideas around computer science, let's just take a moment to acknowledge the breadth of the bands within the computer science, both within the ideas of the concepts and the sub-concepts. So as we prepare to dive into this, be thinking about it through the lens of computing systems, right? The device, hardware and software, as well as troubleshooting, as well as looking at other areas it might touch on. One of the most, I think, impactful areas that was maybe the most, I guess, not considered. I do have some feedback right now. I do apologize. Maybe someone's off mute, but we're so excited to be together right now. Is the one around impacts of computing, because it really looks at culture, social interactions, safety, law, and ethics, which are really an opportunity for us all to look at ways it can engage. And I do thank someone for sharing the tidbit about muting all participants. I'm gonna take a look at how I can do that. I'm a little new to this platform, but for now, if we can just all try to self-monitor our microphones, that'll be great, and then we'll get back to that. So about the Raspberry Pi, you know, really for me, the first time I heard of it, I thought we were really talking about the dessert. But I come to find out, no, it's this wonderful device, a computer that was actually developed in the United Kingdom as a way to support learners in really engaging with the actual computer. You know, we're gonna get back to these slides in just a second, because really what it is it's about thinking about why the Raspberry Pi, right? So often when our learners engage these spaces, they are looking at an iPad, they're looking at their mobile device, they're looking at their Chromebook, right? When you look at the Raspberry Pi, it is a tool that allows you to really see, how am I engaging with this computing world, right? I know I jumped through those slides, and I do apologize about that, just because I had to reorient the presentation for what we're doing, so please bear with me. But as we go back through this, we'll see this device here really is a wonderful tool for engaging learners. Oh my, I really did click through some slides. Okay, what's happening here? Let me just go out of this. I think this is off. Thank you, here we go. We're gonna get here, here we go. A wonderful tool for engaging learners because they're able to see where it's interfacing, right? So for example, we're already familiar with using USB devices. We're already familiar with using our mouse and our keyboard to plug it up into the CPU, but having it in your hand and being able to consider that this device has a series of components that when interacted with allows you to be able to do so much more than you are thinking about than when you would just be able to engage it as just hopping onto that Chromebook, right? So this is a new version out right now. If you are the winner of today's raffle, You actually get a Raspberry Pi 3, but the new one out now is a modular device that it has the ability to come in 1 gigabyte, 2 gigabytes, 4 gigabytes of RAM, which really just give you more computing speed. So for the first time I hooked up the Raspberry Pi, I really wanted to know, what can this thing do? I literally had it going for about a month. I was doing things like getting on YouTube. I was doing things like really being infinitely obsessed with trying to see if I could get it to stream Netflix. I could not get it to do that. But really, it was interesting when I was able to engage learners with it, right? Because when you look at this idea of physical computing, it's this idea of utilizing a tool to be able to help students understand concepts they may not have grasped in a traditional setting. So in our session right now, we're not going to be talking about teaching a specific lesson, but really about engaging this as a learner and looking at open-ending ways we can be able to engage the Raspberry Pi. I know we've all heard this before, but it's really important when working with our students to be open to this idea of a first attempt in learning. It's really not a failure. It's a chance for us to learn more about ourselves and more about what we can do differently as we approach it the next time. So a lot of the resources that I'm going to be talking about today are all available online. Yes, I did share a link to our presentation. In addition to that, though, you actually have access to all of the projects on the Raspberry Pi website. We'll have a chance to look at that in a little bit, but I really would encourage you to go through them and begin thinking about ways you might be able to utilize just the virtual online resources to be able to engage your students. We're not going to do this now. If we were in a space, we would do some introductions. We would talk about where we were from. What we did do is we talked about the looking at who was with us. We know we've got learners K-12, so we'll really just go ahead and dive into this. So here's something important to know about the Raspberry Pi. It really has two aspects to it. On one hand, you can just do a lot of things working directly with the Raspberry Pi, plugging it up into your monitor, your keyboard, your mouse, and engaging it to see what type of built-in programs and peripherals you're able to engage it with. But if you really want to see the magic with it, it's when you would have the parts pack that's referenced here. I had an opportunity to become a Raspberry Pi certified educator by participating in Pi Academy. Now, this really gave me a chance to see, wow, how far you really could go with the Raspberry Pi. For me, my flagship project was creating a ring-like device that could sense something when it approached it, to gather a video, and then to email that video to someone. It was my way of demonstrating how you could be able to utilize a Raspberry Pi to create your own AI interface. It was pretty interesting. And a lot of that type of project ideas are all available for you right to their website. So the model we're working with today is called the Model 3B. So with it, it has some USB ports, a Ethernet port, as well as an audio video port. It has a camera interface, as well as a series of other interfaces that allow you to be able to operate the Raspberry Pi. One thing that's important for you to know is that the Raspberry Pi, without the micro SD card, is really just a piece of plastic with metal on it. You need that micro SD card in order for you to be able to have the operating system on the Raspberry Pi. It literally is what makes it the computer. So as you identify you're ready to engage in the Raspberry Pi, one of the things you'll learn about is the operating system is called Raspbian. There are a few different versions of Raspbian, but Raspbian is an amazing system because it allows you to really emulate that operating system, that computing environment, to have students really get in there in ways that are safe and won't really damage your infrastructure. A moment on that. When we get our Raspberry Pi on campuses, sometimes it can scare administrators. They'll wonder, what is this device? I really don't want to open up our system to things that could be potentially concerning. Well, there's a couple things to know. On one hand, many of the projects that we talk about today actually will be able to be done off of the internet. The Raspberry Pi has a series of programs that are built into it that you'll be able to engage. So whether we're talking about programming from scratch, programming in Thonny, which we'll talk about a little bit later, which is an educational version of Python software, it will allow you to be able to have students engage in the Raspberry Pi and not having to worry about getting on the system's internet. Outside of that, I can share with you, I've done a lot of work with the Raspberry Pi, working with students. I just hooked up my mobile hotspot, and before you knew it, I had students hooked up in teams. We had 20 students together on 10 Raspberry Pis, and it really was an awesome opportunity to be able to get them engaged with that. Let's take a moment to think about what would it be to get set up using a Raspberry Pi. I'm curious, as we think about this, it involves not too much. For example, any of you got old VGA monitors around your campus that aren't being used? You can actually use those for the Raspberry Pi. Get you a VGA to HDMI adapter, and you'll be able to get your Raspberry Pi connected to the system in no time. As you see here, when you're working with the Raspberry Pi, you need to be able to hook up a monitor. I've hooked up an old TV, to be honest with you, with HDMI. You need to be able to hook up a power source, which can be a USB, micro USB power source. You're also going to need a mouse, a keyboard, as well as this micro SD card. Again, that is where you will be storing your operating system, and that's how you will be able to run the Raspberry Pi. Okay, just a moment here. All right, it's important to note when you do get your Raspberry Pi, you got to be mindful of how you're inserting it. If you're working with young learners, you'll want to have them be mindful of the orientation of the micro SD card. On the images here on the screen, it does a good job of demonstrating how you want to make sure it's put in properly, because doing so will cause you not to be able to utilize the Raspberry Pi until you get a new micro SD card. But once everything is all in, you'll see this screen here. Oh, you know now you are getting ready to enter Raspberry Pi land, which is a fun place, because there you're going to be able to do lots of programming as well as engaging students in physical computing. This is a little bit of what it looks like when you prepare to set up your Raspberry Pi. You'll see the screen coming on with the Raspbian software. And then once in the system, you'll be able to see you have loads of options, right? These screenshots really emulate what are the options within there. Now, I want to be honest with you right now. A lot of what we're demonstrating is a series of programming options that you have when you're working on the Raspberry Pi. I did download a Scratch to my computer. However, I did not have the options to be able to access some of the features within Scratch. Also, I noticed some of the features that are available with the downloadable options to your desktop don't give you the same functionality that you get when working with the Raspberry Pi. I say that because one of my ideas as I was planning for today's session was, might there be value in us splitting up in breakout groups and working on a Scratch project together? However, I'm resigned to understand that we have some limitations here. Okay, sidebar, I do see a question here. How do we enter the contest to win? That's a really great question. That's a wonderful question. And what we're going to do is, in a moment, I'll create a Google form that I'll drop in here for folks to be able to enter their name on, for us to do a wheel of names on. It'll be impromptu, but I thank you for the opportunity to work with me on that. All right. So again, this is just some shots here regarding the Wi-Fi. Again, we are on campus. This is not what we're doing right now. So right now, I'm curious, we are not going to do this, but if you would please enter into the chat box by a show of hands, how many of you are familiar with Scratch already? Yes or no? Awesome, awesome, awesome. I'm curious, because so many of us are new to working with the Raspberry Pi. Did you know that you can use Scratch to interact with a physical tool like a Raspberry Pi? You can put yes or no in the chat box. That's awesome. That's awesome. Oh, yes. So I did see a lot of yeses. I did see a couple of no's. So I'll make sure we go through that. So right now, we won't be going into a Scratch lesson, but we'll just do a little overview really quick. So for those of you that don't know, Scratch is a wonderful program to help students understand the conceptualized, to really understand the concept behind programming, dragging blocks, learning how they work together, to understand a little bit about the algorithmic thinking behind it as they bring blocks together and need to make changes and iterate upon it to be able to get their objective met. In this case here, for those of you that are really new to Scratch, you'll know that Scratch is a great platform that allows you to work on your stage, right? It's where you can create some creations. You can add lots of sprites. A sprite is just a fancy way of saying characters on the stage. You can also toggle through different blocks that allow you to do different functions, from saying things with the display of graphics to saying things with actual sounds or words that you could record if you wanted to, right? From there, we typically would do a coding project that would be called Lost in Space. In this project, the students would go step by step through clicking on this link here. That link takes you to the Raspberry Pi website. We're not going to go through the presentation, through the lesson right now, but it shows you that there is a Scratch 3 and a Scratch 2 version of this lesson. And as you click through it, it guides you through what's the goal of what you're going to have your students do through that. I'm hopeful you guys can see my screen as I just kind of clicked away. And then from there, literally it guides you through step by step of doing that lesson with your students, right? So you don't have to be an expert in Scratch. You don't have to be an expert in the Raspberry Pi. All you got to do is give your students access. So when we think about some of these concepts around engaging our students in distance learning, right? And we're thinking about ways we can integrate different fun CS projects or projects related to the Raspberry Pi. On the Raspberry Pi website, what we were just looking at there's actually a whole host of projects that you can click on, right? You can look through any topic, you can look through any hardware, you can look through any software, and see, Scratch is one of those options. And I just would encourage you to consider that as we're looking at ways we can engage our learners. That yes, we can engage our students with the Raspberry Pi, and we can get them started with fun CS projects right now as they prepare to engage this new environment as they're working with us through the time that we're away from each other face to face. All right, just a moment here. I think I'm on the right screen. I'm hopeful I am. All right, and then a big part of that, remember when we were looking at the computer science standards? So I'm looking at Raspberry Pi is 3 years old and the original Scratch and probably cannot do this activity, right? Well, actually, no, this project can be done on the Raspberry Pi. Again, this is the Raspberry Pi 3, and it is operating under the Raspbian software. So therefore, when you're downloading that operating system, you're able to do that using the software that's embedded on the Raspberry Pi. But you're correct. If you download the current desktop version of the of the Scratch, you will not be able to do it. Or if you go to the Scratch website, you will not be able to do that. So yeah, that's a great question added in the chat. Thank you so much. And it helps us to kind of understand, you know, where we need to go if we want to utilize that too. So this here is a really fun activity I would do. I actually play a little song. Let's get physical, right? Okay, sorry. All right, here we would do some physical computing. We would look at session goals around using the Scratch, right, and Raspberry Pi to work together. We would remind students about the first attempt in learning, bringing their code to life. So you may have wondered, that parts pack, what is that? Well, within there are a host of resources that will allow you to engage your students with the Raspberry Pi, right? And for this activity, though, we would typically actually work with some jumper cables. Let's kind of go through that. So there are male-to-male jumper cables, there's male-to-female jumper cables, and there's female-to-female jumper cables. Now, I know that can be a whole anatomy lesson if you wanted to go into that with your students, but it actually is just a great opportunity to understand the functionality between the ways in which you engage the Raspberry Pi. This piece here, this black piece, is called a GPIO pin labeler. If you've ever seen a Raspberry Pi, you'll notice there are lots of pins on it. Those pins are sometimes indistinguishable, especially as you're looking at them with the naked eye. Well, the GPIO pin labeler, that's the general purpose input-output pin labeler, will allow you to understand which of the cables or extensions you're going to be connecting to that Raspberry Pi. All right, let's take a look at this here. And it is all an anti-static bag. Also within that is an opportunity for you to educate your students on some opportunities to see the differences in how things like LEDs and resistors work. For example, one simple way of thinking about this is, if you notice, right, the long end of the LED, right, you see how it has the positive sign? It's almost like the longer side is the plus side. It's longer. Of course, I don't want to minimize the articulation of understanding that, but it's a simple way of knowing, right, which side is giving off which polarity, right? And then if you look over here, within the parts pack, if I'm honest, we really only have 330 ohm resistors, but it's a chance to orient students on the different types of resistors and to understand what happens if they don't use the correct type of resistor as they're creating their circuit. Okay, just a moment here. All right. All right. Thank you so much for sharing that, Vicki. Thank you so much. We got some CS rock stars here in the room, and I'm just humbled to be joining the team. All right, here we go. So here's a graphic. If you don't mind thinking through the lens of the GPIO pin labeler, I really enjoy saying that, general purpose input-output pin labeler, because this does a good job of helping you see how you would orient your program, the physical portion of your components when you're getting ready to write your program, right? Because if you inadvertently selected the incorrect GPIO pin, right, and you had a different block selected in Scratch, one easy fix would be just to change the GPIO pin. Typically, I wouldn't say that in a lesson. A lot of fun to have learners uncover that on their own, but because we're in this virtual space, I just, dispense all of that. All right, here we go. So many times when we're working with breadboards, it'll be a little confusing as to what we're working with. But I want you to know, I learned it really makes no difference where you plug your wire, your jumper cable into the breadboard, as long as you're plugging it along the right rail and bar, right? That means that these rails, this entire rail here is going to result in that polarity. So that means, right, if we look at this, I know this is kind of messy here, right? It's going to walk through it. We know that this entire row here, right, is negative. So whether you plugged it right here, or you plugged it there, or you plugged it there, it really wouldn't matter. And sometimes when we're in the physical computing learning space, we can get so caught up on where we're plugging it, wanting to duplicate the orientation we see on the model, that we lose the opportunity to really understand what's happening when we're making those connections on the actual breadboard, right? So if we look here, this graphic, I feel, does a good job of identifying, right, how those rails connect. Do you see that the entire row is connected with a line of metal, right, that gives it the entire connection? But these over here don't. Same here. They connect on the bars, right? So whether you're talking about the horizontal, right, or the vertical orientation of those lines, it gives you a way of understanding how that works. So I really hope that makes sense by looking at this graphic here on the slide. All right. So I do want you to know, should anyone have any questions, please feel free to type it into the chat box. I'm trying to monitor it as we're going along, just to kind of be a good steward of that. And here, while we aren't doing it, it's always fun to be able to build something. So what I'm going to do right now is take a little pause. I'm curious if you could answer in the chat box. How many of you are familiar with Tinkercad already? If you could put yes or no in the chat box. Yes, that's great. Yes, that's awesome. Not really? Oh, okay, no. Okay, so there's value in sharing. We're not going to go too deep, but I do think it's a great opportunity to share. I'm going to hit escape here. Hopefully everyone can see my screen. I'm going to go back to Zoom, make sure everything is being shared properly. Let me come here. Okay, it's being shared. So when I was in Tinkercad, I was wondering, I would love to emulate this setup, but unfortunately, they don't have a Raspberry Pi in Tinkercad, but they do have circuits. So when you go in Tinkercad and you click Create, you can click on Circuits, you can click Try Circuits, right? And there you're able to look at all the different options they have to be able to create a Raspberry Pi, a circuit, right? Here we're not doing a circuit, but for example, this is a simulation, start simulation. It's showing this as a circuit, right? You can even click here to look at the code, right? There's no programmable functions there. Okay, then I went and looked at Arduino. Now, often folks will wonder, well, gee, isn't an Arduino and a Raspberry Pi the same thing? And I'll often say, that's a great question. In fact, no, they are not, right? And Arduino is a microcontroller that allows you to control specific things within a computing environment. Comparatively, thank you for that. I get out of here. Comparatively, the Raspberry Pi is an actual computer that allows you to engage in Arduino and really do so much more. I'm not going to go into this right now. I'm going to just get out of here. I don't want to get lost in that. So I want you to know that as you're wondering about how those two tools differ, that they are connected. However, they are different in that one is an actual computer and the other controls things that a computer can program it to do. All right, let's get back to the presentation because the Raspberry Pi is not in Tinkercad after all. However, I do invite you on your own time to dive on the Tinkercad, play around with that. I enjoyed being able to create some sample codes that I could copy and paste into my Pi, but given we aren't in a physical computing space, I think it's just better to reference it right now for your later exploration. All right, so here we would have been looking at creating a circuit, right? And let's just dive into looking at doing this on Scratch. So the piece of this that is so interesting for many of us is looking at adding the extension, right? Because when you're in Scratch, often you see blocks, but this more block option gives you the chance to click on PIGPIO, which gives you the chance to be able to integrate this into an actual series of blocks of code, right? So if you look here, right, you would simply have your students begin by having them orient these blocks to be able to think about what they would want it to do, right? So when this clicks, we want this to do what, right? So we know that output low, output high is really referencing the amount of energy that we're going to have go out of that pin. Let's talk about that for a minute. The GPIO pin, general purpose input output pin, means that this pin can be programmed to both receive information, right, if you were to hook up a sensor to it, or to put out energy to a specific device, such as an LED or a motor, right? So when we're thinking about this, when we think about that GPIO pin, we know that we can assign what we want that pin to do. When we want it to go high, we want it to go low, we want it to receive, we can be able to control that within that space. Normally, I would not do a quick reveal of the code, but again, we're in this virtual learning space, so I want to make sure I'm honoring the opportunity for us to look at this. So this is where we would see what that would look like. And here we would challenge our students. What if you were to add a few more GPIO pins? One of the ideas around computer science is the notion of abstraction. It's the notion of taking something that's really complex, and as we abstract, we make it more accessible, right? And as we peel back those layers of that onion, we help to build that complexity, right? Just a little sidebar. I've been reading this amazing book right now. It was recommended to me by an amazing gentleman, Ed Campos. If you're not following him on Twitter, I highly recommend you to give him a follow. And he is helping me understand about this idea around this notion that Zaretta Hammond's book talks about. It is culturally responsive teaching and the brain. A lot of times I mention culturally responsive teaching, and teachers may have heard of it, right? However, this book that Zaretta Hammond writes, Culturally Responsive Teaching and the Brain, adds on some concepts around looking at this notion around a pedagogy of poverty, right? It's this idea that sometimes content might seem complex for our students. It might seem too rich. We might wonder if our students have the intellective capacity to really engage that content. So what do? We water it down, we give them the answer, and we don't give them a chance to really grapple with that content. In Zaretta Hammond's book, she really goes deep to help us understand that when we bring rigor in the classroom, it isn't us giving content that's more complex. Rather, it's us providing opportunities for students to engage content and giving them the space and the support to be able to unpack that content, to be able to make meaning on their own, right? And then we come in with the support to help fill the gaps that they need to help support them, right? I say that because this next slide is on Thani. And quite often educators might think Python might be a little too rich for some of their students. But I'll have you know, Thani is awesome. Here's why. When we engage Thani and we write our code, it actually gives you insight into if you made a mistake, where you might have made a mistake. Often when we're thinking about working with English language learners, we might think, well, gee, are they going to be able to get through all this content? Are they going to be able to understand the importance of syntax? Well, my answer to that is yes, they can. They can if we give them opportunities. They can if we provide the support and the scaffolding necessary to help them really engage that content. So sidebar, Culturally Responsive Teaching and the Brain. Check out the book, it's an awesome book. And let's take a look at what Thani does for us, right? What it does is it gives us a chance to engage that notion of abstraction, right? The idea of engaging something that might have been more complex, so in a way that is less complex. Therefore, we looked at it in the blocks of code. We understood what we were doing. We iterated upon it. We have some new articulations. And now we're taking that same project and we're putting it into Thani, right? And we're looking at this. So what are we looking at here? Just like in the blocks of code, we're calling our extension. So from GPIO 0, import LED, from time, import sleep. You might have recalled the blocks of code were, you're going to, when clicked, you're going to select this pin, it's going to be high, then you're going to wait a second, and then it's going to be low, right? Let's look at this here. We're going to import the LED, we're going to import sleep, and then while true, it's going to be on, it's going to be sleep for 1 second, then it's going to be off, then it sleeps for 1 second. And it's essentially going to loop while true, right? And as we think about building on this, right, we can compare how is what we are doing allowing for students to understand those notions of complexity. When you look at being able to transfer that concept in Scratch into what they are doing in Thani. And this is all in a matter of a couple of days with your Raspberry Pi, right? You spent time unpacking it. You spent time putting it together. You spent time building some introductory code. Now, students are ready to program. Let me tell you, I'm finding students will say to me, you know, Omar, or Mr. Shepherd, or whatever they're calling me, depending upon the space I'm in, I want to do real coding. I want to get off of these blocks. Let's get in and do some real coding. You know what I say? Let's do it. Because I don't have to be the expert. I just have to be the learner alongside, and I have to be willing to allow myself to be open to learning, right? And then we build upon that. We create a flashing LED. We look at ways we can bring in something to support students in adding to their understanding of working with Python, right? Understanding about the notions of adding comments, how that helps us know what we're programming, right? Understanding the notions around adding loops. And again, all of this is available to you all on the presentation link that I shared. This is really just to help us see how we're unpacking the onion in computer science, right? Through looking at the levels of abstraction. If I'm honest with you, when I look at this, can we call it this electrical schematic diagram? It's confusing to me. When this was first introduced to me, it was hard for me to conceptualize how and where this was all happening on my little Pi board, right? But I realized it wasn't so much about me understanding the electrical schematic diagram as much as it was helping me understand what it is that we're learning when we're engaging the Pi, and how what the students are learning will support them as they grow in their learning, right? It'll support them in building what we referred to earlier as their intellective capacity. So here's a shot here of another abstraction looking at it as a traffic light, right? If you were to go from this fully, I don't want to say exploded, but this broad view of it with the breadboard, and then if you were to bring it down into just using it here with the traffic light, it'll give you a chance to do it. So I can actually put the link here in the notes to the slide. It's tinyurl.com/CS with Pi, and that'll be the access to the presentation. All right, looking at this here. Again, more abstraction. I really want to share it with you all, adding buttons and the like. And it really is just a great opportunity for us to look at, ways we can do this. But let's go take a little sidebar for a moment. For those of you that might be wondering, gee, this is a lot of information. I'm wondering, how does all this connect? I want to invite you to write down a website. As I shared, I'm a curriculum specialist with the Orange County Department of Education. Our website is stem.ocde.us, and we've just put together a brand new computer science website. So if you go to stem.ocde.us, I'll put it in the chat here as well, stem.ocde.us. And if you click on, there are two websites I manage. One is the Orange County Robotics Consortium. We aren't talking about that right now. The other is the computer science website, which I need to update. I do apologize, but there's still good resources there. If you would look there, there's a lot of information on the CS standards, why computer science. What I find most interesting, though, is when you click on the resources tab, right? Because that's where you're going to see loads of information around the equity guide, the different types of curricula that are out there, as well as looking at different types of programming you can use to engage your students with, right? I know I'm going kind of fast just because our time is dwindling, but I do invite you to visit it and explore, because as we're in this space right now, we're trying to figure out how can we be successful in this remote learning environment. It might be finding some of these projects, finding some of these lessons and ways we can utilize them to be able to engage students, right? So really quick here, let's look at this. When we were engaging in computer science standards through the Raspberry Pi, we were looking at things like computing systems. We were looking at things like algorithms and programming, impacts of computing. They're all spaces for us to look at ways we can, connect with the California computer science standards. So what I'm going to do right now, if you would give me a moment to pause, I'm going to go ahead and set up a Google form. And in this moment here, since we've got, this opportunity for us to connect in this way, let me see if I have the option. I don't have the option to set up those rooms. Okay, I invite you to take a moment to go ahead and visit the website. I'm going to drop into the chat bar for Raspberry Pi and take a look at some of those projects and take a look at some of the options as it relates to software, as it relates to any topic, and maybe share something you find interesting you can engage your students with. I will be back in just a moment. I'm not going anywhere. I'm going to just go ahead and set up the Google form for the giveaway of the, okay, this is totally, oh, there it is. The Cana Kit, which is actually unopened with the Raspberry Pi 3. Okay, hold on. And if anyone has any questions, now's a great time to unmute yourself if you'd like, and I'd be more than happy to chat with you. It's been so great to connect in this opportunity. It's actually my first CUE presentation. I'm very excited, so thank you for the opportunity.
Omar, I have a question.
Sure.
I got a Raspberry Pi. I went to the CUE conference last year and I talked to someone. I didn't go to a presentation, but I talked to someone about a Raspberry Pi. Loved it. Bought one for my classroom for my STEM class. And I have a breadboard. I have all that stuff. But my problem is I'm not sure how to teach them how to use the breadboard because I don't know it at all. Is there some place that will take them step by step through something like this?
You know, that's a really great question. You know, we really kind of powered through this presentation. I would highly encourage you, when you have a moment, to click through it more slowly, as there are several pictorial diagrams that offer you support with seeing exactly where it goes. And may I ask, what area are you located in? What county?
I'm in LA County.
Oh, okay. Well, you know, I'm actually located in Orange County as well, meaning local. I know we're under a quarantine now, but I'm really just an email or a phone call away. I'd be happy to support you. I'm sure if you were even willing to come to any of our play dates that we do or pop by the county office, I'd be more than happy to walk you through it. But again, the presentation is an awesome place. I'm seeing in the chat box here that there's some great supports in Tinkercad to help you with teaching your students how to do the
and
breadboard.
Are they able to open Tinkercad on the Pi, or do they need a separate computer while they're working with the Pi?
Well, Tinkercad really wasn't meant to be working on the Pi. Really, the Pi is not meant for a lot of online work. It can really get slow. It's just really to demonstrate that you can do it with it, in my opinion. You can, but it sometimes doesn't work as well. So I would say if they have a Chromebook, they could be doing it on a Chromebook. If you have regular computers, they could be doing it there as well. And I think any of those would really be great. Okay, I apologize. Here we go. So we're going to call this I really hope that was helpful. And again, you can feel free to email me anytime. My contact information is on the slide.
Thank you.
Sure. Okay, so basically, on this form I've created, it is just going to be a really simple form. I'm thinking I need to know your name, email address, where you want me to mail it to if you win. But if you don't want to share your address unless you win, that'll be fine. Maybe I'll just delete that question. Just a moment here. I'll just get your address if you win. And I don't need the phone number either. I'll just delete that. And then feedback if you need on there. Okay. So try to create a quick tiny URL. All right, so hopefully you're having an opportunity to take a look at some of the projects on the Raspberry Pi project's website. For those of you that are, if you wouldn't mind sharing maybe one that you're coming across that you find interesting, that'll be great for us to hear.
Can I ask a question about a kit?
Absolutely.
So I'm having trouble deciding which kit to purchase. I need some internet connectivity. I'm trying to build a network with Raspberry Pis for my lab, but I'm not sure which is the best option. Like, do I just purchase the newest kit? And if so, what is that? Or do I have to purchase add-ons like Wi-Fi add-ons or something like that?
Well, the Raspberry Pi, now let me ask you, when you say create a virtual network, is that to use the Raspberry Pi and it will be the virtual network? Because
it might be a web server, or it might be that just set up a network where they can see how the sort of mini computers communicate with another.
Yes, absolutely, because there are several projects where you can create networking applications where the Raspberry Pis all talk to each other, and that 100% is a thing you can do. I don't know that you'll need to purchase anything additional. My understanding, though, is you will need to be on some Wi-Fi system. So it may be a conversation you'll need to have with your IT department if they have any issues. Because here's what happens. The Raspberry Pi doesn't have some of the authentication procedures you would have with other tools. Do you have third-party verification for Wi-Fi at your site?
I'm sorry, what was the question again? Third party
So
what?
when you get on Wi-Fi at your site, do you have a verification process you have to go through?
If you're within the domain, there is no verification process.
Okay, because ultimately you'll have to have it on one Wi-Fi for the rest of them to communicate with the one. So even if you have a hotspot for your cell phone, I use that all the time, and I hook up my Raspberry Pi to that, and it works very well. All right. And may I ask how many students you have in your classroom?
The biggest class I have is 37.
37? So yeah, that would really be an amazing networking project. And I highly would encourage you to look on the project page. There are lots of ideas of ways you can be able to do that. And well, you can also email me or drop me a line separately. I'm at Dr. Shem on Twitter, and I'd be happy to chat with you about that further as well.
But offhand, do you know which is the newest kit or best kit? If not, I can email you later.
Well, the Raspberry Pi 4 is the latest Raspberry Pi.
Okay.
However, we're raffling off the Raspberry Pi 3.
Okay. I'll still submit my name though.
Okay.
All right. Thank you.
Sure, absolutely. However, so basically, let's say you win the kit. Let me just kind of walk you through this really quick. If you were to win the kit and you're ready to use it, you're going to need a monitor, you're going to need a keyboard, you're going to need a mouse, and you're ready to rock and roll. You've got the Raspberry Pi. There's a cool little kit that you can build it into, and you also have the GPIO pin label sheet, not the labeler. To make it the best use, you'd likely want to utilize, it does have an HDMI cable as well, yes. You likely want to utilize there are questions coming in here. A parts pack, which is about $18 online, and it's a great way for you to enhance how you're working with your Raspberry Pi. All right, so I'm going to go ahead and go in the form now. Hopefully everyone has had a chance to fill it out. I want to see if it's working. I have some responses in here, and we will create. I'll give you another minute or two to drop your name in the form. And meanwhile, I'm going to go to a different site here under, excuse me, my name. And then I'm going to go to tinyurl.com/raspberry raffle. All right, so for those of you that might not be familiar with it, I use a site to generate the winner. Let me see, there is this, well, okay. To generate the winner, it is Wheel of Names. So I'm going to just try to get in the form here really quick. I happen to be using my wife's computer, so I'm having some challenges, but it's going to be all right. Hashtag better together. All right, thank you, everyone. Here it is, Raspberry Pi raffle. And let's go ahead and get in here. We're going to go into the, go into the responses. We're going to go into the spreadsheet. We're going to go to wheelofnames.com, which is really fun. Okay, and we're going to just look at this here. All right, there we go. I'm going to Control-C to copy, Wheel of Names. Who are these people? Sorry, Control-A, delete, Control-V, and then we're going to hit the button here. And the winner is Donna Gatz. You are the winner. Winner, winner, chicken dinner. All right, Donna, if you could please email me at my email address, oshepard, OSHEPHERD. I could even drop it in the chat here. Let me see. Where is Donna? Donna Gatz. There she is. I'm giving you my email address. please do drop me an email with your name and address where you'd like this mailed, and I'll drop it in the mail. In fact, it is unopened. How cool is that? Okay, on behalf of OCQ, sorry. All right. Well, hey, you know, I'm so humbled for the opportunity to present with everyone. I'm to present to you this afternoon on the Raspberry Pi, the little computer that can. And I do highly encourage you, when you have a moment, to visit the resources we've shared. Don't forget to take a look at the presentation. Again, it's tinyurl.com/CS with Pi. And thank you, thank you, thank you. And if you're not doing anything now, we're about to hop into the OCQ affiliate meeting, which will be getting started in about 4 minutes. So I'm really excited about that. So if there aren't any further questions, I'm going to go ahead and hit stop recording.